Hi everyone, my name is Piyush and in this video I will be demonstrating my solution for task 3.1b in SIT 210 embedded system development. The task was to create an embedded system using the Arduino Nano 33 IoT and the light sensor to track sunlight exposure for a terrarium. The system needs to send me notification whenever sunlight starts hitting the terrarium and when it stops. To do this, I'm using a platform called IFTT, which stands for If This Then That. It's an online automation service. In my case, the Arduino is this part. It detects sunlight, and IFTT provides that part by sending me notification to my phone. Now, I am explaining you hardware setup. First, I have the Arduino Nano 33 IoT, which is important because it has Wi-Fi built in. That means I can connect it directly to the internet without extra modules. Secondly, I am using a BH1750 light sensor. This is digital light sensor that communicates with the Arduino over I2C and give a very accurate reading of light intensity in lux. The wiring is minimal. The sensor SDA and SCL pin connect to the Arduino I2C pins and then power and the ground are also connected. With this setup, the Arduino can continuously read how much light is falling on the sensor. When the value is high enough, I consider that sunlight. Now I am giving you the code walkthrough. Firstly, at the top, I include the libraries, wire, and BH1750 for reading light levels. Wi-Fi Nina for Wi-Fi connection, and Arduino HTTP client for making HTTPS request to IFTT. Then I enter my Wi-Fi detail, the IFTT host, and my personal IFTT key. I also set the event name Sunlight Start and Sunlight Stop. I also define two thresholds. If the lux goes above 200, the system thinks sunlight has started. If the lux drops below 100, the system thinks sunlight has stopped. Having two different values here prevent flickering when the light is unstable. That's called the hysteresis. Next, I have some variables in sun, which keep track whether we are currently in sunlight or not. After that, there is state change MS. It saves the time when sunlight starts. Then sun accum today ms keep track of the total sunlight time for the current day and day start ms is used to reset counter every 24 hours. The function connect the Arduino to my Wi-Fi and keep retrying until it's successful. The function read lux is the lux value from BH1750 sensor. The function send IFTTT event is the important one. It built a webhook request and sent it to IFTTT with some optional values like the lux level or to total sunlight minutes. IFTTT received this request and triggered for my notification. The check sunlight function is where the main logic happens. If the system was not in the sunlight and the lux goes above 200, it detects that sunlight has started, record the time and send the sunlight start even to IFTTT. If the system was in sunlight and the lux goes below 100, it detects that sunlight has stopped, calculate how long that sunlight lasted, add it to the daily total and send the sunlight stop event. Finally, in the setup, the function I start the serial monitor, initialize the sensor, connect to Wi-Fi, and set it the day computer. In the loop, function I just called check sunlight every second, so the Arduino is constantly monitoring light level and talking to the IFTT when necessary. Now I am explaining you the IFTT side. I created two simple applets. The first applet listen for the sunlight start event. When it receives, its action is to send me a mobile notification saying something like sunlight detected to lux is equal to 250. The sunlight applet listen for the sunlight stop event. This one send me notification that include the total minutes of sunlight today, the duration of the last sunlight burst, and the lux level at the moment. This make it easy for me to check sunlight exposure for the terrarium constantly, checking the Arduino. Now I am running my code. To take this system, I repeatedly simulated sunlight by using a torchlight and covering the sensor each time. Now, when I use my torch to do this, you can see sunlight extracted option as there. And if they note is stopped, and there is also notification occurring there. Now, let me demonstrate the system. At the moment, the sensor is in a darker environment, so the lux reading is below 100. If I look at the serial monitor, it shows a low value and the system is the no sunlight state. Now, when I shine a torchlight directly onto the sensor, the lux value jump above 200. The Arduino detects sunlight has started, set the state to the true, and immediately send a webhook to IFTT. Within a few seconds, I receive sunlight on my phone saying sunlight has started. Next, when I cover the sensor again, the drop below 100, the Arduino detects sunlight as stopped. Calculate how long the burst of sunlight lasted and send another webhook. This time I get a notification that shows the total minutes of the sunlight for today, the duration of last burst and the lux value. This proves that the system correctly detects both sunlight starting and stopping and integrates the IFTT for real-time notifications. In the In this task, my project successfully used the Arduino Nano 33 IoT and BH1750 light sensor to measure sunlight and integrate the IFTTT to send notification. The Arduino handles the sensing and logic, while IFTTT handles the cloud side and notification. This shows how embedded system can be connected to the web services to create smart and useful solutions.